Now, thank you so much, everyone, for joining us for this next webinar in our infectious disease and climate change webinar series. I see a lot of familiar names joining us who've been with us on some other webinars. It's really nice to see people returning to this webinar series, and welcome to everyone who is new. Before we begin, I just want to acknowledge that the Canadian Public Health Association's office is situated on the ancestral and unceded territory of the Algonquin and Anishinaabe people. They've been the guardians of this land for millennia, and we are grateful for the example their stewardship provides. CPHA is committed to working with all First Nations, Inuit, and Métis people and their governments in realizing meaningful truth and reconciliation. Today's webinar, Modeling the Future of Arctic Fox Rabies Dynamics and Associated Risk Management, is brought to you by the Canadian Public Health Association through the Infectious Disease and Climate Change Project. I'm Gillian Pritchard, Project Officer with CPHA, and I'll be the moderator for today's webinar. Before we begin, I want to take a few moments just to let you know about some CPHA resources that we've been developing through our infectious disease and climate change project. So the first one, for those of you who haven't heard me talk about it before, we've recently compiled a bunch of tools and reports and research and podcasts and webinars, all speaking to the topic of infectious disease and climate change. So we've compiled all of those on our website. So you can find those at cpha.ca in our resources section. So I'd really encourage any of you are looking to learn more on this topic, that this is a great place to start. There's been many organizations across Canada working on some pretty interesting projects, which you can find there. And then as well, we have our Infectious Disease and Climate Change in Canada Key Informant Interview Report, which we recently launched, which gives an overview of conversations we had with 16 different key informants, all from across Canada, working in the fields of public health, infectious disease, and climate change. It really outlines some of the opportunities and gaps we have going on in Canada with relation to this topic. So again, you can find that on our website. I'd encourage you all to check it out. Just for a bit of housekeeping before we begin, I'll let you all know that all of our attendees are muted. And if you do want to ask a question, just please type it into the Q&A box below at the bottom of your screen there. If you have any questions at any time during the presentation, please type them in there. At the end of our presentation, I will read out the questions and allow our speakers to answer them. If you're having any technical difficulties, please also type it in the Q&A box, and then I can type back to you. And if multiple people are having the same issue, then we will address it live. Just a few quick notes that this webinar is being recorded, and the recording will be posted on CPHA's YouTube channel a few days after this presentation, so you can rewatch it there. And also at the end of the presentation, when you close Zoom, our post-webinar survey will pop up in your internet browser, and we'd really appreciate it if you could fill it out. It's just really helpful for us to get that feedback. Now I would like to introduce our speakers for today's presentation. Dr. Patrick Leighton is a professor of epidemiology and public health at the Faculty of Veterinary Medicine at the University of Montreal and an active member of the Epidemiology of Zoonoses and Public Health Research Group. His research focuses on the ecology of wildlife diseases that are transmittable to humans, and in particular, the impact of ecological change on the epidemiology of these diseases and the risk they pose to public health. He has co-developed and co-directs University of Montreal's master's program in One Health and Veterinary Public Health. Also joining us today is Agathe Allibert, who is currently a PhD student at Grezop under the supervision of Dr. Leighton. Agathe's PhD explores the impact of climate warming on future rabies dynamics with applications to rabies risk management in the Canadian Arctic. After a master's degree in France in 2014 in ecology, evolution, and biometrics, Agathe worked for 2 years on Réunion Island as a statistical study engineer in tropical agronomy. I'll pass it over to you two now.
Thank you for the introduction. We're just going to queue up our slides here and we'll get started. And thank you for the opportunity to present. It's a really nice webinar series, and we're really happy to be able to contribute today.
We're happy to have you.
So Agathe and I are going to divide this presentation into 2 parts. I'm going to talk about sort of the research program we've had on Arctic rabies for the past 10 odd years. And then Agathe is going to give you some more in-depth results on some of the modeling work she's been doing as part of her PhD. Can go to the next slide. So rabies in the north is sort of an iconic One Health issue. On the one hand, you have a wildlife reservoir, in this case, the Arctic fox, which is the primary reservoir maintaining Arctic fox variant rabies in northern Canada. Arctic foxes then transmit this disease to other wildlife and to domestic dogs and people in northern communities. So there's an exposure either directly from encounters with rabid animals or indirectly through exposure of domestic dogs, which then are in the community and can bite people. So it's transmitted through the bite of a rabid animal. What's interesting in this case is that we have a really strong environmental component potentially here, one that hasn't been fully explored, which is the dramatically warming climate of the Arctic. And so everything about the ecology of the Arctic ecosystems is changing right now. And this is, there are a number of things that are likely to impact the persistence of wildlife rabies in the north, and also the frequency and intensity of rabies outbreaks. Rabies is currently endemic across most of the Arctic. And so the questions become, how is that going to change with climate warming? Go ahead, Agathe, for the next slide. So the research program that we've been carrying out over the past 10 years is focused on a number of different questions at the interface between wildlife ecology and disease ecology and epidemiology of rabies. So first of all, where and when does rabies transmission occur? There was a first phase that, well, we won't present much of the results here, but where we tried to quantify where in space and time these encounters between wildlife and domestic animals were occurring around northern communities. How does rabies persist in very low density carnivore populations that we see in the north? And this has been a bit of a puzzle because in theory, rabies should not persist given the classic epidemiological models, but yet we see it. And so what are the specific aspects of Arctic rabies that allow it to persist in these very low density environments? And then as we're going to talk about today, what are the impacts of climate change and to some extent northern development as well on rabies dynamics and the risk to people? Go ahead, next slide. And I should say our title, Modeling Associated Risk Management, isn't truly correct for this talk. We're going to talk about potential applications to risk management, but mostly we're looking at the dynamics of rabies in the north under climate change. So specific interest to our public health partners in Quebec and elsewhere in Canada are some direct questions. When will the next rabies outbreak occur? We know that rabies is cyclical. Typically, anyway, there's outbreaks that are more major in years. It used to be every four to 8 years potentially, and that seems to be changing. Are we able to get some insight into how frequent rabies will be as the climate begins to warm beyond its current state? What's the risk of rabies spillover to southern regions? And as you can see from the drawings on this map, this is a map of previous rabies incursions into the south from the northern reservoir. So this is Arctic rabies strain, Arctic fox rabies variant, spreading south through red fox populations. And in fact, you can see that some of those arrows go all the way as far as southern Ontario. And in fact, our Arctic fox variant is currently established in Ontario, is still present as it did a host shift from foxes to skunks and red foxes, and has been maintained there for many years since one of these big spread events. So as you can imagine, having rabies spread down from the north, we're not talking about raccoon rabies here, we're talking about a rabies reservoir for which we have no vaccine barrier between the north and the south, simply geography. How often is it likely to increase or decrease the probability of future spillovers is a key question to try and solve here. And then, in this context, what are the best strategies for rabies control or management in the north, guiding surveillance, et cetera? There's some very specific applied questions we'd like to kind of start to get some answers for. Next slide, please. So overall, this research program objective has really been to gather the various data sources initially needed to understand this issue better and start to produce tools for rabies prevention and management in the Arctic. And the tools we're going to present today are mainly modeling initiatives, but also some data synthesis that I'll talk about in the next few slides. Next slide, please. So specific objectives here is to test the associations between climate and meteorological variables and these rabies outbreaks that we see over time using time series that are available. The Canadian Food Inspections Agency has been in charge of rabies surveillance for decades and has a very long time series of reported rabies cases that allows us to look back in time and see how things may have changed. And I'll talk about that in a minute. Then to produce epidemiological models coupled with climate data that allow us to look forward. So what's likely to happen with climate warming in this ecosystem? And then finally to see what ways we can transfer this knowledge both to residents of the North and then also relevant public health decision makers at various levels of government who might have an interest in better managing Arctic rabies. Next slide, please. So what are the sources of data? What do we know about rabies? And I mentioned how it's cyclical, and you can see the past surveillance time series from the CFIA of rabies cases in Arctic fox, that's the AFX, and red fox RFX. And you can see that this particular graphic starts in 1984, but surveillance goes way back into the 50s in various ways. And so you have a sort of a classic rabies outbreaks scenario, and you can see that those outbreaks are occurring fairly synchronously between red fox and Arctic fox in these regions. These are data from across the Arctic, so there's obviously local outbreaks that are going to be happening at different times, so it's not a perfect lineup. But one thing that's worth noticing here is that this classic pattern of big outbreaks followed by years of not much activity seems to be breaking down, or at least changing in recent years. And this time series stops in 2010, but we've seen similar situations where it seems like rabies may be becoming more endemic in certain areas and less of it's always been endemic, but having more of a regular and lower level pattern of outbreaks. But this is still partial. So we also have traditional knowledge from northern communities, and quite a bit of it about where and when rabies outbreaks are occurring locally. We have good information about fox ecology, population dynamics, and behavior that helps inform some of these hypotheses and investigations. There are a lot of trapped foxes. Foxes are still trapped for fur commercially, and being able to partner with trappers to obtain carcasses once the fur has been removed to then test for rabies has been a very helpful way of getting some more information. And then we have information about genetics from these same types of samples that allows us to better understand movement and barriers to movement of foxes and how that might be spreading rabies around. And Agathe will talk about that a little bit later on. Next slide, please. So you can play the GIF I get. So this is just a little data visualization of some of the CFIA collected declared rabies cases that have been tested and confirmed. The orange circles are red fox and the white circles are Arctic fox. And this is just for the northern Quebec, Nunavik, Nunatsiavut regions, and then also Newfoundland, Labrador. And what you can see is this is just for one of those 4-year periods where this is what a rabies outbreak looks like at a broader scale. And often, though not always, you can see a bit of a spatial pattern there. And so, you have, in this case, you have a first case at the northwest tip, and potentially that came through migration from another region in Nunavut, for example, and then you get a pattern of cases in around there and then spreading across. We don't really know what's happening in the central part of Nunavik because nobody lives there to report cases, and so these surveillance data are partial, but they give us a portrait of sort of the space-time patterns of how rabies is potentially spreading geographically. Next slide, please. Up on the right, we have Audrey Simon, who's a postdoc in my lab who finished a few years ago and did some of the work that I'm going to be presenting here. And so one of the first things we wanted to do, go ahead to the next one, is to see if we could make associations between this long time series of reported rabies cases and climatic variables. So we corrected for fur return. Obviously, declining fur trapping is going to have an effect on how many cases we see, and then looked at how annual sea ice coverage could be affecting the frequency of rabies outbreaks, and then also temperature and precipitation. So in terms of sea ice, the hypothesis here is that more sea ice means that foxes can move around more, and moving around more means spreading rabies and coming into contact better. And there are two data sets that I'm presenting here. The first one is a 10-year study from 74 to 84, where there was actually active surveillance. So going out and trapping foxes and testing them for rabies, which is a great deal of effort and gives you sort of a better indication of the actual prevalence on the ground. And then on the right, there's passive surveillance. So these are contacts with people between presumed rabid animals, and those animals were tested. And so there's a higher chance of detecting a rabid animal through that system. And so we tried to analyze both of these data sets in different regions to see if we could draw any conclusions. The sea ice wasn't very conclusive. In the active surveillance, it seemed that the greater sea ice with a 1-year lag was actually resulting in fewer cases, which was against our hypothesis, whereas the only place where there was a significant effect in passive surveillance was in Labrador, where we saw the expected association where greater sea ice was actually leading to greater probability of outbreaks and cases 1 year later. So with transmission happening during the winter, presumably, and contact resulting in increased chances of having a major outbreak the following year. Next slide, please. So then we were looking at temperature with a 3-month lag, variation in temperature and precipitation, and overall, and this was more in keeping with our expectation, is that warmer winters and rain and snowier winters are actually associated with lower chances of having an outbreak, and which would suggest that perhaps as climate warms, it might have a dampening effect on rabies spread in these northern environments. But that's what we were able to draw from the statistical associations. There's also strong associations between the timing of rabies outbreaks and winter foraging and mating versus the more sedentary periods of parenting and juvenile dispersal. So that was a first look at the data and what we could get out of analyzing the data in that way. Next slide, please. And then based on some of this information, we built a 2-species epidemiological model, a susceptible exposed infectious model, where we had a population of Arctic foxes and a population of red foxes, and we allowed them to spread rabies between those populations. And we wanted to look at the impacts here specifically of changes in food resources, and also the degree to which red foxes are increasing their presence in the north, which is a documented phenomenon, that there are greater and greater numbers of red foxes. And that's also these are two things that may happen, and we're starting to see with climate warming, is that the habitat becomes better for red foxes, and they have a higher competitive advantage, and then they're therefore able to establish and actually exclude Arctic foxes from some areas. And then also changes in lemming population cycles are expected with climate warming, and Agathe will show you some more on that later. But essentially, the decrease of lemming cycles was something we wanted to see, since lemmings are a very important food resource for Arctic foxes. So that was the first question we looked at. Well, what happens if we have strong lemming cycles versus weak lemming cycles? And in a strong lemming cycle scenario, we have these and that's what you're seeing at the bottom here, we have these very strong outbreaks in Arctic foxes and red foxes that are essentially synchronous. But with, I wouldn't say chaotic dynamics, but less regular. I mean, we have basically, because the cyclical lemming populations are intersected with the cyclicity of rabies itself, where it kills a lot of the susceptible individuals and then it can come back later. You get these kind of 7 to 8 year intervals between peaks, but that aren't quite as regular, as you can see. Whereas as lemming cycles begin to weaken, you end up in a more cyclical, regular sort of 4-year outbreak phenomenon. And then finally, with no lemming cycles at all, or it flatlines, you get more of an endemic situation, but where the actual frequency of rabies cases is much lower than it would be in outbreak years. And so it seems that with decreasing lemming cycles, it might be driving the system more towards an endemic rabies situation, where rabies is at a lower level than it would be in these explosive outbreaks that were characteristic of rabies in the Arctic in the past. Next slide, please. This was just a slide to see what happens if you increase the presence of red foxes, and essentially outbreaks get more higher amplitude, so greater number of cases, because there's just more animals in the area to be infected, and then also more and more synchronous as transmission between those two species becomes stronger. Next slide, please. So what that model didn't have was a spatial component to it. It was really modeling a population of foxes in an area the size of northern Quebec and seeing how that would work. Now, some excellent work by Dominique Berthaud and his team in Violet Island in the high Arctic has been documenting the movements of Arctic foxes around a goose colony in this area. And what you're seeing here is a little video of how Arctic foxes move in winter. Each of those little clusters of points with lines is 6 daily movements that are observed, and you can see what they're doing in a given day, and the time step of the video is daily. What is interesting here is these are individuals, and the scale is, you know, this is fairly large scale, but we're not seeing, first of all, we're not seeing necessarily all these foxes in winter doing huge movements, which is, I got to talk to you about, that is something that foxes will do. But what we are seeing is that they're really using that sea ice when they're out in the blue area. That's winter sea ice. And at one point, you know, you may have seen a cluster of activity. They seem to be gathering around possibly carcasses of seals or things like that. And so that sea ice really is important, both for movement and also for contacts in winter that could facilitate transmission. So what we wanted to do is start to bring some of this spatial information into the models that we were looking at, because the hypothesis was that really for rabies to be maintained in some of these areas, it might need to be reintroduced from far away. And so not accounting for that long distance movement was potentially missing a really important driver of rabies persistence in this system. Next slide, please. So just very briefly, another postdoc in the lab started analyzing these movement data and was able to sort of classify the types of movements that foxes were making into these 4 different classes, sort of home range, sedentary movements, which is mostly what we were seeing in that video. You could have animals that were doing nomadic movements. This was a smaller proportion. I think about 80% of foxes were displaying some sort of a sedentary movement, but then you get these nomadic movements where they're just kind of wandering around all winter. And then you have 2 other classes which are interesting. One is a dispersal movement where they go from their initial home range to some other location and never come back and establish a new home range. And then you get these migration movements where, and these are the ones that are very interesting, the 2 long distance movements where they'll go 1,000 kilometers during the winter and then come back to the same home range they were in initially. And this is partly what makes Arctic foxes famous, is that they do these really long movements. However, these were relatively infrequent in the population, but being able to capture these different classes of movements and simulate them, next slide please, allows us to build this movement into these models. And here's simulated data of movement based on the analysis of those. And we're able to capture that type of movement. This would be a nomadic, I think, trajectory for one fox pretty reliably, and therefore be able to integrate it to start to look at space more specifically. Next slide, please. So that brings us to the second part of this talk, where I'll turn it over to Agathe to explain what she's been doing, which is taking this idea of epidemiological models and then spatializing it so that we can really better understand how the spatial context is potentially going to affect both the sort of the local epidemiology and also the long-term persistence of rabies in the north. Over to you, Agathe.
Hello, so thank you, Patrick. So I'm Agathe Allibert, and I will present some part of my PhD on preliminary results about my spatial epidemiological model. So in first, just to remind, it's about global warming, and global warming is expected to influence the epidemiology of rabies in the Arctic by affecting habitat quality for foxes, spatial and temporal distribution of foxes, and the movement, behavior, and interaction with other species, especially red foxes in the Arctic. And all of these things can also affect rabies by Arctic foxes. And so we use a mathematical, stochastic, individual, spatially and temporally explicit model. So it's a lot of things I will explain. My model is mathematics because it's mathematics, you use number, and it's good things for you because it allows us to simulate a scenario and recreate a situation. So we can just try a lot of different scenarios and see what's happened. And it's a model stochastic because some events happen with a probability draw from a probabilistic law. So each simulation is unique because it's very important for when it's about simulation of things who are very rare. And it's an individual model because we simulate each fox like in a video game, and it's spatially explicit, and so we can see the effect of landscape in the rabbit dynamic and the foxes dynamic. And it's also temporally explicit because we do each simulation by the week. And the use of the type of model, the advantage and limitation. The advantages, it allows prediction and understanding of complex ecological mechanisms. And we work in the Arctic, and the field work in the Arctic is very difficult and it costs a lot. So use a model, it's less difficult and less cost, so it's a very good advantage. And the limitation is a model cannot completely represent reality. And what we choose is which reality, and it depends on the modeler choice and the modeler question of the research. And so for my model presentation, the input of the model are landscape. We use a virtual landscape with hexagonal cells. And in each cells, there are virtual foxes and one and a lot of foxes. So a lot of foxes. And each foxes can live, die, and do a movement in this virtual landscape. And after we had a disease, here the rabies, and I can, in my model, and the output are about foxes and disease, so I can use this for my simulation and to analyze the output of my question. So it's very modeling, it's a very big modeling. And for us, a big challenge, this modeling is a big challenge for us. So we therefore read a postdoctoral at the University of Montreal. Is François Viard, as you can see here. And he's developing a Python library, SAMPy, for stochastic adjoint model with Python. And he's very interested in working with other people. So if you want to use his library, here is his email. So do not hesitate to contact him. And in first, I will present the influence of the spatial distribution of resources on the dynamics of Arctic fox rabies in northern Quebec. So it's about lemming and cyclicity of lemming. And the main question here is how do the spatial and temporal distribution work in northern Quebec? And why it's very interesting? It's because there are two ecotypes in Arctic foxes, especially in the Nunavik, in the northern Quebec. There are foxes who are in the coast, and they eat remains of marine animals, and it's a more stable resource. And the foxes who are very in the inland, they are feed mainly on lemming, and lemming is not a stable resource. They are a cyclical resource, and there are years with a lot of lemming and years without lemming. And we suspect that resource can influence the rabies outbreak in northern Quebec and at a spatial scale. So there are hypotheses. The Arctic fox ecology and the local lemming population cycle can influence the local dynamic of rabies in Canada far north. So to study that, we use lemming long-term data capture to model fluctuation resource in central Nunavik in the south. And after we're modeling a cessation of this cyclicity in response to climate change. So as you can see here, it's a long-term capture in one land, and it's the variation, the carrying capacity variation in all central cell, they are in brown. So we're just modeling cycle exactly like the lemming data and after stop of the cyclicity. And we analyze the consequence of the cessation of cyclicity of a spatially distributed resource. So inland lemming and in the coast marine mammals. And we studied we studied that at the fox population and disease level. And so we do all this simulation in the circle. So it's not a map of Nunavik, it's only a circle, but it's allowed to see the spatial the result. Here you can see the result. It's the number of foxes with rabies in the circle map when we have a lemming cyclicity in the center of the map. So as you can see, the rabies is only on the coast. and rabies do not across the map. And when we stop the lemming cyclicity, when we have the lake resources, the rabies can across the map. So those Arctic fox ecology and local lemming cyclicity influence the local dynamics of rabies in Canada farmers. Yes, especially in there are difference in coastal area versus inland. And after, I will present the influence of the disappearance of sea ice on the dynamic of rabies at the pan-Canadian scale, because Arctic rabies is not only problem in the Nunavik, it's a pan-Canadian and pan-Arctic scale problem. So here we have the main question. So the winter movement of Arctic foxes by connecting individuals explain what is the break dynamic was the Canadian scale on the UK chapter, and that Argos data in Below Island. So Arctic foxes can do a very long movement, and they can spread the rabies in all the Canada and all the Arctic. So we hypothesize that climate warming will cause a spatial isolation of Arctic foxes population across northern Canada, and somehow the Canadian that were previously endemic for rabies will become rabies-free because they'll. So we predict highly connected Arctic fox population will become genetically isolated from each other, and it will decrease the risk of rabies across the Canadian Arctic. So for this question, we use the current and future limit of the Arctic sea ice. We allow fox movement when the pack ice is present, and we are modeling the Canada with rabid dynamic and genetic isolation of foxes and simulated no in the future. And yes, so we allowed to fox are allowed to move in the ice when ice is available under different scenario. And we because two scenario of sea ice extent in the Arctic versus a global warming scenario. And this global warming scenario is here. It's a GIF of the global warming scenario. So as you can see in the global warming scenario, sea ice disappear in the Arctic during the summer. And we use for the long distance movement, we use the Argos data of Dominique Berthaud on the island of Below. And is the data. Here you can see the long distance movement of juvenile in Below Island. This is considered 20% of the fox studies. And we studied genetics, and for genetics, we place 10 mates across the Arctic. Each couple have same alleles, defined by the other couples. Here is the place of the 10 mates. And so we can study the progressive genetic homogenization of fox over time under the two different scenarios, historical and the future scenario with climate warming. And here, first, in the result, we try to link the fox Argo data from Dominique Berthaud with the historical ice scenario data. So it's this GIF to see if we could see them moving in the ice over time. As you can see here, the foxes making long movement more than the ice as it forms. So we have very good data. We can use this. They are agree together. The fox do not go in the sea. And for the result, we have less heterozygosy in the climate warming scenario than in the historical scenario. So as you can see, the beginning of the simulation, and in the historical scenario, we have a lot of heterozygosy increase by the time, because foxes go and they are met over foxy. And with a scenario with a big climate warming, there are very less heterozygosy because fox cannot cross the sea ice. So warming would lead a gradual spatial separation of Arctic fox population that were once connected. It's validated. There are less heterozygosy in the climate warming scenario than in the historical scenario. And one next step is to study rabid dynamic in the model. And so we are trying to study rabid dynamic in the model. And here in the map, it's a map of rabies in the model in the Pan-Arctic area. As you can see here, we allow us to cross the sea ice. So area is in the Pan-Arctic scale. And the fifth objective is to transfer the knowledge obtained to improve the management of the Arctic rabies. So along my PhD project, I do some transfer on college in school. For example, here in School Direct School with my colleague Emily Bouchard. And here we animate an necropsy of foxes with Kujak School with a study. So thank you for your attention.
That was wonderful. Thank you so much to both of you for your presentation today. It was so interesting, and it's fantastic to have those GIFs there to really be able to see where foxes are and how they're traveling through the north. I'd like to remind all of our participants now that it's a time for a Q&A. So if you have any questions for our presenters, please type them into the Q&A box below, and then we can read those aloud and answer them for you. To start us off, I'd love to learn more about translating this information to the local communities. Is the modeling that you're seeing similar to what they're experiencing in their communities? And how are you working with them, or do you have plans to work with communities around rabies?
I can address that somewhat. So, I mean, as we initiated this project, I could see some of the collaborators here on the line, Ariane Massé and Audrey Simon and Emily Bouchard, who've been involved in the North. One of the first things we did was to connect with several communities where we were interested in trying to understand what their impressions were about fox locations and interactions with dogs and how things were changing over time. So we had a quite good discussion as we were beginning to look at those interactions and fox movements, and overall their knowledge about where foxes should be at different times were adding up to the type of movement data and also interaction data that we ended up connecting and collecting. And so that's been a nice sort of connection point, because they have real concrete sort of information about foxes and interactions that are likely to be well, that are connected to the type of data. Also through the trappers that have been involved in the monitoring work. That's obviously a direct connection there. What we'd like to do is, once some of these results are actually a little bit more tangible and feasible to communicate, So we have ongoing work in especially northern Quebec, where a lot of this began, where in Nunavik and Nukchuak and Kuujjuaq, to be able to sort of discuss. And I think maps are a very useful way of talking about this, because those GIFs and then more static kind of maps over time really give a good visualization for how risk might be changing. And so I think the plan is to then, once those are a little bit more solid, is to have some interesting discussions and see if that adds up to the recent trends that people have been seeing or anticipate. People's viewpoint, however, often tends to be very focused on their own village, and a lot of these patterns are broader than that and wider range. So it'll be interesting to see in discussion with different villages whether there are some commonalities that are emerging or whether it's very localized. And one thing Agathe has done, I mean, I should let her speak to this, but with Institut National de Santé Publique and Ministère de la Santé here, we have a project to try to map out risk and how that might change at the village scale across Nunavik. And so we're able to produce with these models some sort of projected, heat maps of geographic risk over time and in space. And I think those will also be useful for communication, because they're at the scale at which people are interacting with this disease on a daily basis.
Yeah, I think that's really great. We've seen from other projects that we've highlighted in this webinar series that I think those maps as a communication tool can be very helpful for people to engage with the science and really understand, what their risk is. Just a reminder to all of our participants, please type in any questions you have for our presenters into the Q&A box. They'll be happy to answer them. You can follow up. So what I'm getting from this is that climate change is likely to decrease the amount of rabies that we see in the Arctic. This sounds like good news. Is it, or are there maybe some unintended consequences of that, or is there still some big question marks within that?
Agathe, did you want to address that?
Yes. By disappearing of sea ice, it can be a good news in local point. But we think that, for example, in Nunavut, there are a big population of Arctic fox, so it's probably disappear of rabies in local point, or still have rabies in other point of the Arctic. And for foxes, it's not a very good news, because as you can see, there are less heterozygosy in our modeling, so they're probably isolated. They will probably isolated some foxes
Okay, yeah, no, that's a good point.
Maybe just to add to that, I mean, the other component that we haven't really fully explored yet is the probability of rabies spillover to the south. And so while locally good news, there's other studies from Alaska also that are showing a similar potential trend with climate warming leading to reduced rabies overall. But this is sort of, very vague predictions, as is our case. We haven't got, it's not a very specific prediction at this point. And there's still a lot to be worked out. But let's say that is the case. What we don't know is if extreme weather events and starvation, as has been shown to lead to mass migrations of animals in the past, could actually have the opposite effect on increasing the frequency of spillover to the south. Among other things, if red foxes become more established further north or get higher densities, then they're theoretically a bridge to the south, because if you have higher density red fox populations, then it would make it easier for rabies to spread south through the boreal forest and so on. And so a combination of extreme weather events and greater presence of red foxes in the north might actually increase the frequency of fairly important spillover events. Now, that's very difficult to predict, but if we see that that's more likely overall, then that could be a sort of fairly negative consequence, at least for public health in southern areas.
Absolutely, that's something really good to consider. Got a question here from one of our participants asking, how does your research and conclusions compare to the Arctic fox rabies realities in other Arctic regions?
Go ahead, Agathe. Did you?
Okay. So I go ahead and you complete. So yes, for the three, we sorry, we work with a team on Alaska who work in Arctic rabies, and as Patrick say, they support the hypothesis, but we do a hypothesis in the very long-term scale. And no, there are not a lot of data in this scale. So we predict in the far future, and for now, there are not a lot of rabies in the Arctic with climate change, and we do. There are not a lot of study for this, so we are yes, we are alone.
So I could add to that, and thanks for the question, Hugh, who is the grandfather of Arctic fox rabies research in Eastern Canada for that insightful thought. And I have partial answers as well. Audrey Simon, who's on the line, if you'd like to add to this, please go ahead. You know, Alaska and southern Quebec, or sorry, northern Quebec, Nunavik region actually have quite a few climate similarities in that many parts of Alaska are you know, warming, and the climate is different, but it's more similar to sort of southern Arctic regions than it is necessarily to the high Arctic. And so we are seeing some similarities in terms of composition of red foxes and becoming more abundant, and the coastal context being similar. So I think we can draw some parallels between Alaska and Nunavik, Labrador there. And the study by Audrey looking at kind of the climate aspects found similar conclusions to what studies in Alaska had found. However, the high Arctic situation, I believe, was more similar to what we're seeing in Greenland. And I'm not sure about Scandinavia. It's quite a different situation over there climatically and geographically. And then obviously there's Russia, and I don't have a very clear sense of what's happening there. Maybe Audrey, you could complete if you have other information. But so qualitatively, Alaska and sort of Nunavik, Labrador are showing maybe similar trends, and then kind of Nunavut and Northwest Territories to some extent may be more similar to Greenland, neighboring Greenland, but beyond that, I wouldn't venture much further.
Such a vast area to study. I expect there can be a lot of heterogeneity through it. I don't see any more questions coming in, so I'd like to just give you an opportunity. Do you have any last words before we conclude? No.
And so thank you for inviting us.
Yes, of course. We're so happy to have the both of you.
Yeah, thank you very much for the opportunity. And I think, you know, this is, we decided to present, you know, some historical work and then some ongoing, you know, unfinished work, with the idea that I think it's useful to see where some of this is going. But I think one take-home message is that, you know, the Arctic is vast and data are sparse, and some of these questions are really difficult to address no matter what approach you're taking. So I think that what the future holds is still quite uncertain, but hopefully some of these, you know, assembling data and trying to make some of these models will at least guide us in terms of overall what we might be expecting in the future. And hopefully some of that will end up being useful and also informative to local communities with regards to climate adaptation and health.
Well, thank you both for taking the time to share your work with us today. It was so interesting and really fantastic to learn more about what's going on. And thank you to all of our participants for attending today as well. If you could take a moment once you close the Zoom to fill out our post-webinar evaluation, which will pop up in your browser. It's just really helpful for us to get that feedback, so we'd really appreciate it. And so thank you all for joining us today, and have a safe